We've talked a lot about the connection between two-dimensional geometry and three-dimensional geometry, and that's going to continue as we talk about the idea of volume. Volume, at its essence, at its core, is dealing with area. And to kind of show that to you, I've got a couple pictures up here on the board. Right here we've got a rectangle. This is a 2 centimeter by 1 centimeter rectangle, and as you can see, it has 2 squares on it. Right next to it, I have a 3-dimensional rectangle, we call it a rectangular prism, that has also a 2 centimeter by 1 centimeter, but its third dimension is also 1 centimeter, a 2 by 1 by 1 rectangular prism. If you took it on the side, you could call that a square prism too. Now, the connection might be obvious, it might not. What I want you to see is I want you to see that this is 2 squares. We would write that as 2 centimeter squares since they're 1 centimeter by 1 centimeter. Over here we've got not 2 squares, but we have 2 cubes. We would write that as 2 centimeters to the 3rd power. But there's a connection there, hopefully, that you can see. This is 2 squares, 2 things that we fill up with area. This is 2 things, 2 cubes that we fill up with volume. Because of that, we can apply it down here to a more difficult problem. If I said, what is the volume of this rectangular prism? How many cubes could I fill this thing up with? We could take the idea of the base, 1 layer of cubes. Well, 1 layer of cubes is just 2, the same thing that we had up here. That 2 is the same as this 2, right? Just a different unit. They're cubes instead of squares. Now we can take that and we can think of it as layers. We've got 1 layer of cubes down here at the bottom, and since it is 5 centimeters tall, we know that we can fit 5 layers until we get to the top of this thing. Now, what that means is that we've got 2 things happening 5 times. We know that we're going to fit 10 cubes inside of this thing. So we would say the volume of this is 10 centimeters cubed. But do you notice the connection? If we focus on just the numbers, how did we come up with that 10 centimeter cube? Well, the 10 comes from the 2 and the 1. Right? The 2 and the 1 say that we have 2 cubes. Right? 2 and 1. And it comes with the additional height, that additional height of 5. Well, 2 times 1 times 5 does give us the 10. But this 2 and 1, right, well, we can think of it as it coming from the cubes, or we can think of it as coming from our squares. Now, I only say that because eventually it's going to be very, very helpful to think of volume in that way, as a layering approach, right, starting with area, right, and building that area a bunch of times until we fill up this 3-dimensional shape. So a formula that we're going to use over and over and over again in our study of 3-dimensional geometry is that volume is the area of your base times your height. It's kind of something that happens one time at the bottom and then happens over and over and over again depending on what your height is. So volume equals the area of your base times height. And we'll get to a couple more videos showing examples of just that.